All right, let's just give this a go. This is not my wheelhouse, making videos and stuff, but thought I'd give it a try anyway. Start with the business end of this Lifereef dual pre-filter box. Dual siphon overflow, hang on back style. What you got is this outer box hangs on the back of the tank. This is a 210 gallon display. Hang it on any standard trimmed or non-trimmed tank. It's a little bit adjustable that way. At the end of the day, we're pushing water out of here at 900 gallons per hour. So we're averaging 450 gallons per hour out of each of those 1-inch siphon tubes that are slung over the back there. There's a corresponding box inside the display that we'll get into in a sec here. But dual 1-inch drains, those are 1-inch tubes, those U-shaped tubes. It's my understanding and my belief that an open gravity fed, wide open 1-inch drain can max outflow at 600 gallons per hour. So this pre-filter box has a 1200 gallon per hour rating, theoretically. So this system, if run wide open, to my experience now, after almost a year of tinkering with it, not like I've spent a year doing it, but I've just been hard to make time for this project and cash flow and all that. So it's just been a tinker toy hobby. But over the course of many months, been tinkering with this and flow testing and trying to make all this run silent. To do so, it requires you slow these drains down just a little bit, adjust them with a gate valve. And when we slow them down, it can become risky with this overflow style setup on that hangs on the back. What I've done by slowing it down though is the turbulence between all this water charging up in like what would be the size of 2 cans of beer, 900 gallons per hour, just in this little center chamber. The action on this water whipping over this wall is real kind of sporadic and makes a lot of splashing noise, opens up air cavities, which then whip down the drain tubes, which are open 1-inch channels, open 1-inch PVC drains. Creates burping and air noise and gurgling in the system. So I'm trying to calm down and smooth out all of this overflow transition everywhere for the sake of silence throughout the entire system. It's a little more risky, so we are going to add an emergency drain to this. I've machined a test sample. Here is what would represent the side panel of this overflow. I've machined for a bulkhead, which I'll do right here. You can imagine that bulkhead will be above the normal operating height. And if one of these drains were ever to get clogged, or if a fish got through or a snail or whatever, this drain system slowed down, the return pump in the sump is not going to slow down for it. So this will want to have a tendency to flood in a hurry. Who knows how many gallons by the time you catch up with it. So the idea here, because I'm going full siphon and getting the air out of the system and making this run quiet, we want to implement a third drain, what we'll call an emergency drain. If any of this slows down for any reason, we will get drain noise coming through into the sump, and I'll point out where that will go. This one will not have a flow control on it. It'll just be an open channel that purposefully dribbles into the sump to make noise, so it will call your attention that something is happening. Otherwise, we want the normal 2 circuits to run quiet. We'll point that stuff out now. I'll take that fitting out of there so I can show off the hole a little bit later. To the left of that box is a 1-inch PVC return in the black here. This is a third return I recently added for a UV sterilization loop. But the idea is we're returning the water into the tank here. It floods the display, overflows into the inside box. We start a siphon here on these 2 tubes, blast water in. This box carries it down to the sump. The business end of this, I I have these in here. These are just some insulation noodle, you know, plumbing insulation noodle. These would normally ride here, but I found they actually smoothly flow better if I hold them in this outward position like that and keep them from moving around randomly. So this serves another purpose too, where it almost closes all this off, so trickling noise actually isn't so audible, and it really reduces evaporation out of here because I've mostly closed it off with this. It's kind of a win-win. This is stuff that I can easily work with from the front side of the tank when I'm on my stool. Keep in mind this will all be closed tight up against the wall, so we won't have access to all of this. So yeah. Also, in an effort to control the whipping over here, I've found that just leaning this sponge, this pre-filter sponge over and reducing the space in here has also helped from whipping air bubbles, and then it just perpetuates noise. So I've added just these little pieces of sponge just to make these lean over a little bit. It's just been helping me. Again, it's something I'll easily be able to grab from the front side of the tank for service and know how to drop it right in there. This is nothing more than a 1-inch open standpipe. I've tinkered with the height on those standpipes to try to change the level in this box to maybe make it quieter. Nothing really seemed to work. It ultimately always balanced itself back out, so I'm back to the original standpipes. So that's really all it is. It's 2 open 1-inch drains that could have the potential for 1,200 gallons per hour collectively. I've got them slowed down based on a time study to about 450 gallons per hour each. So that's draining 900 gallons an hour into the sump. You match the return pump speed back to that. So this is a 230 gallon system. You know, we're somewhere in the 4.5 times per hour turnover just through the sump, which is nice. I have a couple for extra credit, a couple of other hang-on back filters you'll see here when I start moving around. Just the Aqua Clear 110s. So for extra credit, can run scrubbers and chemical filtration in those, whatever I feel like, just extra. To get closer to six times per hour turnover. Turns out these Aqua Clear filters, even packed full of media, still flow about 300 gallons per hour each. So there's close to 3 more times per hour just by hanging 2 cheap filters on the back aside from this system. So near about 1,500 gallons per hour total, which is great for a 230 gallon system. We're turning it over, I don't know, 5-6 times an hour. That's great for me, even more, you know, it's awesome. If I open the drains wide open, it'll definitely flow 1,200 gallons per hour. It just does it with noise. It's nice to know that we can do that any given day if we're maybe trying to filter some meds out after a cycle of medication or any other thing. You can definitely speed it up for the day when silence isn't required and flow more through it for sure, and then dial it right back down at the end of the day and steady it off to be silent. Not sure if I wanted to cover anything else. Now that I took that pre-filter sponge out, there'll be some there'll be some dust and debris in the tank. It won't be very clear. Messing with that, it's loaded full of debris right now. Been soaking driftwood in here for quite a while, so light dirty particulate is in all this sponge. Okay, I guess we'll go really quick to the inside box. So the outside box hangs on the tank. The inside box attaches to the outside box. They call that a Lifereef Overflow, I guess is the term. It's a kind of a standard in, I guess, hydrodynamics and the way they make dams and flow and control the level of the higher body of water. So in this system, we need the display level has to be higher than the level inside that box. Doesn't have to be a ton. The more you go, the more noise it will make. The higher you go, the less effective it is at surface skim. So I've been able to, over the course of time and tinkering, figure out a nice sweet spot where I can operate it for several days, many days, and keep a good skim and keep quiet and all that stuff. It's kind of interesting how it all worked out. The slots in that weir comb are 1 inch tall. I'll call them 1 inch tall, and they're 1/4 inch wide. And the amount of distance in there, it's lower by about 3/4 of an inch. And it's tough to see, but I'll try to zoom in. If you look inside there, you can actually see the bottom of the water level in that inside box. So I'm looking at some solid water column near the bottom of those slots. But that's representative of about the 5/8 of an inch drop, that waterfall I've got going in there. Just to give you an idea. You need that in this to work real well. Let's try to get back to 1. Okay, so again, sorry about glares and stuff. This is not my thing. I don't do these types of things. Let's step back here and give you a quick idea. Don't have the blackout on the back. There'll be some static privacy film on the back, so you won't see any of that stuff through the display. This will all disappear. That black box will disappear. I could also add that all this white Home Depot plumbing was just set up, many months ago so I could get testing. It was never intended to be the actual stuff that will get built into the final installation when I move this up front to the office. All this mess of wiring gets whipped up into a sweet, tidy control panel. This is all just test mode here, so forgive all the mess, the glare, and the clutter. Just wanted to try my hand at this. So you can see the aqua clears. They're just extra credit. Might as well utilize the hang-on real estate. I like that they provide awesome surface agitation. Helps create circulation too, to stop the dust from collecting so bad in spots, just making different flow patterns in the tank. So what else? Oh, the returns, the primary returns, not including the one I pointed out for the UV. That's a third one that's separate. But there's a return on the other corner there. Return on this corner here. Where we at? There we go. It's coming out from underneath. This is 1.5 inches coming out from underneath the tank, and it turns into 1 inch here, 1 inch up and over the back. These fittings get glued, but that last one does not. It actually hangs on there, so you can kind of point it around and change the direction or whatever, but you see that there. And if it was to pop off, no biggie, because that one's glued on and it'll just still be spitting water into the display. It won't be a party foul there. It's pretty nice, that Lifereef. It doesn't stick out any further than a standard HOB. Jeff did a really nice job packaging the design and getting the depths set accordingly to make all this work out good. I guess let me do this. So I guess I'll point this out. Cheap ball valves, Home Depot. The idea behind the valve for a ball is not to make adjustments, but to just shut off for service. Use gate valves to make adjustments, flow adjustments. And using a DC controlled pump, you don't really use valves to control the return. You use the digital controller. So this is just a shut off for service, so I can take apart this return, rebuild it, redesign it, clean it, service it, whatever. So the system is serviceable and interchangeable. The new valves that come in here, it's a true union ball valve, where the union and the valve is all one unit. Just thought I'd mention that. This is a Spears true union ball valve. I'm sorry, it's a CPEX. The gate valves are from Spears, as are the nice gray Schedule 80 fittings. Spears one-way check valve, swing gate style. These are a couple of true union ball valves from CPEX. These will not get sticky, salt water, fresh water. Those Home Depot valves I knew would only last a month. They were useless to make adjustments with or shut off for service, but I put them into place for the test purposes early on anyway, but they're absolutely useless after a month, 2 tops. They don't work, especially to make adjustments. They didn't work to make adjustments when they were new. They're not a good adjuster valve. These operate super smooth. I got a second one here with the inlet coupler off. It's pretty slick. They send this little tool, and if later on down the line this starts to leak internally, let's say it doesn't shut off all the way, you come in here and you just give a little snug to that seat, snug it back up, and that nice Teflon ball in there will seal better. Pretty slick. Gate valves will get installed on the drain. They won't be sticky, they'll last long term, and they're capable of making way finer adjustments to that drain to slow it down. You want to only slow it down what you have to make it quiet, to make full siphon, and then there's your maximum flow that you can achieve, you know, at that point. So gate valve for the drains. One-way check valve is going to go into my returns. I don't have that installed yet, but I do have one on the new UV loop. The returns over the top, I'm going to change to these furniture grade fittings, but all the business end of the stuff down below is going to be the thick, heavy duty Schedule 80 stuff. These will look a little sharper that hang in the tank. We'll go over that in a second. I thought that was cool. This is the new black PVC that'll go in there. Form you fit. You can get the black furniture grade or any color they offer for that matter. Form you fit. I'm not affiliated with these companies. It's the stuff that I've worked out myself. What is this company called here? Aquatic Experts. Aquatic Experts. This dual density fiber pad I found, it beats the crap out of everything else. I bought a 24-foot roll for $70. It's going to last a year in that sump. I went ahead and I'm using it for a few different things now. I made little thin plywood templates for the pad sizes. AC110, that's the AC70, it gets 2 of them. AC110. I've changed in the trigger sump from socks to pad. I'm not using the socks. It's ridiculous. I have gotten recently onto this. It's the hammerhead model for 1/2-inch thick glass algae scraper. Algae free. These things are beautiful. Really happy with that. Okay, here we go. I'll try to go slow. I don't know what to make of this. This is probably all a waste of my time. Try it anyway. So, as mentioned, I've got 2 returns, one in each corner. It starts underneath with an 1.5-inch return, but then tees. Lots of driftwood. It's been a great filtration experiment because of the dirt, the sediment, the tons of nasty, weird biofilms and shit that grow out of that. It was crazy. It was great to clog filters and show me how the way scale builds up on this stuff, and it's kind of neat. It's all pretty much in the past now, which is I'm thankful for. Let's try to take a seat here and smooth this off, or maybe let me go up in the front one time. The loud buzzing in the room too was not this setup. It's underneath that workbench. There's a real loud step down transformer. The buzzing in the room. I know these cameras are sensitive. So, like I said, those slots, it's deceiving because we're looking down into the water, but they're 1 inch tall, those slot openings. Like I said, you need the water level inside that box needs to be lower than, 3/8 of an inch, 1/2 inch is fine. You can see there in the center, there's a wing nut. It's all plastic stuff. This inside box gets hung on that outside box and retained at that wing nut, and then there's some sliders off to the side that keep this thing lined up vertically. But you can adjust this inside box up and down, and that's going to change. You can do it to your desired water level height, your display tank height. So I can lower that a little bit and lower the water level, certainly could. Raise it a little bit, but I'm up pretty high. I'm up as high as I'm comfortable with, and I'm up high enough to satisfy pretty much normal operation on a hang-on back filter with a quiet discharge chute kind of dipped into the water there. Nice thing about the sump design is it doesn't show evaporation ever in the in the display or even in the first couple of chambers of the sump. Evaporation now only shows up in the return chamber down there. So that's that. We are pushing 900 gallons an hour into that overflow. We started the siphon on those 2 tubes, shoves it into that outside box, shoves it through those baffled areas, those chambers, just lets it drop right through that dual drain system. 1,200 gallons an hour capacity. We've got it slowed down. So, whoa, okay. Get this out of my way there. So again, it'll look real nice when you black out the back of the tank. You won't see the return nozzles. I mean, you will see the return nozzles. You won't see the returns or any of that filtration on the back. It'll all kind of disappear. Dual drains, 1 inch. The consensus is that on the drains, because these are not pressurized circuits, instead of 90-degree fittings, you'll do 245s anywhere you can, and it smooths off the flow. So I'm coming down and then across, and then in that back corner of the sump. It's kind of an industry standard, dual 1-inch drains. It's about as low as you'd want to go in a 200+ gallon system, but I'm making it work. You can see that those 2 ball valves there on the left are kind of closed. That's the difference between 1,200 gallons an hour and 900. I've slowed those 2 down to basically hold the water back, and it keeps it all quiet. It was making little air, lots of air, and then it would surge and bubble and gurgle. So, first chamber of that sump, it's just a tall vertical column, and kind of the way the dual drains into a real small narrow area up in that overflow, because it's got a screwed on cap, it doesn't allow you to get in there real conveniently to clean. So that's just a lot of biofilm and scale buildup from that driftwood over many months. I think I was in there 6 months ago or more to clean. The other chambers I can wipe out and clean. This is where there was 3 filter socks that I've eliminated and gotten away from. I don't like the filter socks. I don't like the service on them, and this is a freshwater setup. So I'm going to go to the foam experiment. This is just a first iteration with layers of different PPI port foam. I'm going to cut this up different ways and continue to experiment, but you get the idea. Water is dropping through that chamber. Messing with the sponges and that stuff, it ends up making it nice and quiet if you try to be quiet. So, the opening at the bottom there is where it's all coming out. Where are we at? This chamber and that chamber are going to run the same water level, because you can see that they're open to each other in that baffle. If you put a piece of filter media there and it slows down a little bit, you will get a slight drop between those 2 chambers, but otherwise they're the same chamber right now. They're just divided by a wall. This first chamber, so the water is coming out the bottom and it's heading up halfway point, and then it heads up higher to another weir overflow like upstairs. This is showing the same kind of a dynamic where there's like a 5/8 drop, just like I've got set up upstairs. That creates good surface skim in the chamber. Those last 2 sections are tied together. They're always going to run the same level also. There's a foam in this skinny overflow chamber there that's coming on too. I like to keep my water level just a little bit above that. It doesn't let any splashing happen. Anywhere from an 1/8 inch up to a 1/2 inch max, but 1/8 inch, 1/4 inch, 1/2 inch max. I let this thing kind of fluctuate. You can see the water line there. Afterwards, there's another little tray down there. It's an ideal spot for some chemical filtration. There's some Purigen in there to help me with my driftwood tannins. That was a neat experiment. Stuff works good. I'll continue to use it. I will probably run Chemi Pure Blue in there too, just for clarity. You got here, this was plumbed in a long time ago. This, where are we at? That was the primary return pump, 1.5 inches. That's just a service shut off. It's not to control flow. The pump controllers are over there. Pump on the left, pump on the right, controller on the left, controller on the right. So single 1.5 up to a T, 1.5 inches out to that back corner, 1.5 inches out to that back corner, and I've already pointed out that it turns into 1 inch right after that 90. Overkill, yes. I didn't want restriction. I want it wide open because the outlet of the pump is 1.5 inches. So I want to not make any restrictions ahead of time. I want to get it as far as I can at no resistance. Less strain on the pump, in my opinion. All this stuff gets replaced with those Gucci Schedule 80 gray and the black PVC pipe and all that. Those gate valves will go here for fine-tuning the drain speed, like I pointed out. I will have a ball valve there. That first compartment is going to get packed full of all the ceramic, porous, sintered glass type media to set up biological filtration. May run a small sponge filter in there for aeration as well, and to keep that chamber kind of moving more. The days where I pull filters out of there, we want to try to keep it clean in here, so I will throw a temporary pad up against that opening right there to keep this chamber clean and that chamber clean. Keep it out of the pump areas, right? Because this stuff is going to let, as you stir it up, it's going to make this chamber dirty. No biggie to get it on biomedia because you can rinse that and wash it off in a bucket of tank water. But we do want to keep the pumps clean and the return water clean, especially this first pump. What I did here is dropped in a secondary pump. It's a dedicated pump there for UV. This is just a 1-inch channel. Put a check valve in there already because there's a UV lamp involved in this circuit that if that pump were to die, we don't want that to empty out. We want to hold water in the lamp so it doesn't melt down and create a house fire. It's a redundancy. Again, that valve is just for shut off and disconnection purposes for service. It's not to control flow because I have a DC controlled pump. That controller on the left is covering that pump. We just dial it in that way, the pump speed. So 1 inch going in, that's a 25 watt UV sterilizer, and we adjust the speeds a couple of different ways depending on what we want this unit to do. I think normal day-to-day stuff, I will run it at about 130 gallons per hour. And if I ever get an algae bloom or a bacteria bloom, I'll run it at about 300 gallons per hour. Challenge that poses running 2 different pumps. I already spoke to the 900 gallons per hour that I'm flowing through the drains quietly. So I can only return 900 gallons to that display. That means if I want to run 130 gallons through this separate circuit, I have to reduce the other one by that same amount because I can only total that 900 gallons per hour. I can't outrun the drains, otherwise I'll flood the display, right? Set my drain speed to my liking and then adjust the return pump accordingly. So this is part of the return, and I've added a challenge of making it on 2 pumps. The advantage though to not just pulling a manifold loop like a lot do off the primary return, like where's my finger at? There we go. They'll start running other circuits off this return line, off this return, and make it a manifold, drop a bunch of different circuits in accordingly. They'll feed their UV sterilizer from that with a valve and then just return it right back into the sump there. From my research, it's kind of ineffective and a waste of time, so it's best to dedicate a loop. And actually, no matter what you do, if you do take it from a return off the manifold style, it's still better to return it to the display so it blends in with the volume of display water. People argue that returning it right into that return chamber, well, it just gets sucked into the return pump and ejected into the display immediately anyway. However, you'd be surprised. There's some water that sits in there for a long time and almost never, it doesn't always all get returned out of that little chamber. It's not the case, so it's a little more ineffective to my research anyway. I was convinced to go the extra mile and set it up on a completely separate circuit, return it to the display. So that's the gist of it. I started this test without the UV loop and just learned it all and learned how to set the flow and the levels on all the water without the UV loop in play. Then added it later, knowing, like intuitively saying, hey, if I'm going to take some more out of that system, I got to slow down the other primary pump to balance it out because the drains only flow that fast. Okay, so yeah, I guess we can talk about packing hardware. I did start talking about this. This first chamber packed full of biomedia. You can add a little sponge there or do some stuff here and there periodically, and you can put stuff anywhere you want. It doesn't really matter. There are strategies to it. Because I won't be setting this up. Normally a saltwater setup will put a tall protein skimmer in this first chamber. It sticks up out of here. Depending on the manufacturer of your protein skimmer, they'll call off a water line, a water level where it works the best. This weir comb there is adjustable up and down. That gate goes up and down. As you raise that gate, it will raise the water level in those two chambers, but it will lower the water level in there. You'll need to readjust, add water to the system or whatever to reestablish your desired levels. But if I raise that gate, it will raise the water in those two chambers. It's not a huge deal to me right where it goes, but I've settled in a spot that I like to satisfy more than enough water, excuse me, over that intake orifice. Some people run it dangerously low to that intake orifice, and I don't like that because if it slows, if it speeds up or the drain slows down at all, it's so quick to empty that return chamber out. I like to have a little extra depth in there. There is a strategy to, it's a 40-gallon sump, but you're not putting 40 gallons in it. There's maybe 25 gallons in there. In the event of a power outage, those two pumps shut down, some water is going to back siphon back into this thing until it breaks siphon up top. It breaks the siphon in the return nozzles, not in that overflow box, which is nice. That thing stays primed. When the power comes back on, water continues to overflow out that overflow box. That's not a problem. The returns have to break siphon, so there's a certain amount that is trapped in the returns, and then of course the display level has to drop until it lets air into those return nozzles. You need room for that water in here. You can't let this overflow in a power outage. Now, the check valves shouldn't be relied on. They do keep it pretty operational the way it is. It shouldn't let much in there as long as they function well. The swing gate design on the check valves seems to be my preferred method. I looked at the other couple of common styles, and I convinced myself to go with the swing gate style. They're not to be counted on for absolute flood prevention, but they're convenient to have. It's a union junction for service, and in the event you want to shut one of the legs down, or if that pump burns out, it won't let that circuit empty out, and that 25-watt lamp inside that blue box won't melt down the PVC chamber that it's housed in. It's an intense UV lamp that you can't look at. They got it all captured inside of a PVC chamber. So what else should I speak to? More about the chambers here. I will pack 2 heaters. I got 2 500-watt titanium heater tubes that are going to lay on the floor in there. The controllers for the heaters, temp controllers, will go on a control board over here. It's going to look all real sharp and tidy. I swear you won't see anything but controllers for lighting and pumping and stuff, and switches and stuff like that. All that stuff gets tidied up, but it's nice. We can put hardware in here. The heaters and all that stuff can go in there. It's great. Some people opt to put them in the tank, or one in the tank and one in the sump. You can do all kinds of stuff with these. It's great. They do refer to this narrow chamber here, this overflow chamber in here, as a bubble trap. Some of the marine guys, they get a lot of pumping action in here and they make bubbles, and you don't want the bubbles to end up going into the intake of your pump. It puts micro bubbles into the display, and obviously it can cavitate the pump some. It can cause premature problems with that. So the idea is to try to prevent bubbles in this last chamber. So they call it a bubble trap. They put a foam sponge there. It's a very coarse, like 10 ppi, and it just simmers down that water. It doesn't let hammering or trickling. It's real smooth, still calm water in this last return chamber. So speaking to the returns, this tank on the width and depth dimensions, it's 24 inches front to back, 72 inches end to end. So 72 by 24. Every 1 inch of water level is about 7 or 8 gallons of water. So those return nozzles are like 2 inches more, 2 inches deep into the water, right? That means 14 gallons has to drain out of there before that water level gets down to those openings, those return nozzle openings. Well, I got about 16 gallons of headroom in there. It's alarmingly close to overflowing. Don't like that either. So what we do, I got those filters in the way now. Much closer to the water level, my water line, I got it turned so you don't see it so much. Let's go over here. You might be able to see it. There it is. On the side of this black return, I'll zoom in. I got about a 5/16 diameter hole drilled in the side of that. It's not even it's like a ½ inch below the water line. So now that will break siphon when it starts to backflow really quick. It's only going to drain 5 gallons back into that sump, 7 gallons to max, back into my sump in the event of a power outage. It leaves me more than half of that headroom left, which is very nice. So all 3 of the returns have that. That's your first line of siphon break. Again, sorry about the glare, guys. You can't see them in that. The filter's in the way. I've got that nozzle turned, but oh yeah, there it is. Got it. It's just below the water line. I got that siphon break, and you can see it's above the halfway point of this 45-degree fitting. It's above that even. It's in that leg, just below the water line on the other side. So all 3 of those nozzles will break siphon quickly. And in the event that I shut that down, that whole sump system down, I can continue to leave the aqua clears running because the water level is up high enough to satisfy those to continue to run. So I can do a whole sump service day with it all shut down and keep some filters running, for the day, and even throw another one on there, kind of slick that way. I'm sure there was other stuff I wanted to talk about. It doesn't really matter. This is going on and on. It's going to take forever to upload. I bet it never even works. But that's the racket, man. I'm happy to just try this for once. I don't know, there's it's tough to really kind of tell, but you can see the water level is definitely lower. Maybe I'll go over here. You'd be able to, you can see through the, so you can see up through the, well, let's go to the other side. If you look up through the inside, you can see how the flood water in that inner box, there we go. There's some daylight in there. It's running near the bottom of the weir comb slots there, where the water level is. That's been my target anymore, is to have some visible solid water near the bottom of that slot like that. That works out really, really good. Keeps things quiet, keeps the surface skim working really well. Again, it's kind of dusty now. There's some algae dust, and there's 2 weeks of algae on the inside of the glass here. It's kind of fuzzy. It's weird. See all the reflections of the machine shop in here. Neat. Belinda's Driftwood on Facebook, if you don't know about her, if you're into that. Amazing pieces. I've been picking up from her for the last year and just getting them in here and starting to waterlog them. Not sure what I'm going to do with this tank yet. It's just going to be freshwater tropicals to get started. I know there's more I wanted to mention or discuss, but it's enough to maybe provoke questions, and I was just trying to do a video. This all gets taken apart in the next month or so. I can powder coat the frame and get it ready to move up front. I'm doing a little wood floor project, or a fake wood floor project, where this goes in the office, and making prep to do a bunch of stuff, and finally get my yo-yo loaches into a nice bigger tank that they deserve. Oh, evaporation. I did mention evaporation. It's pretty slick that these systems, now the evaporation only ever shows up in that return chamber, this collective two last sections. You can see that it's open. They're open to each other under there, so they're the same chamber. Evaporation only shows up there. I will definitely be setting up an automatic top-off system, where it'll be off to the side another little reservoir that'll hold 5 gallons or something like that, because I keep a covered tank. I did pull the center lid off today just to show in there a little bit better, but I keep lids on my tank. But so far, even leaving this sump open, which it's dusty in my shop and office, I will probably cover that thing with polycarbonate by the end of the project here, to keep even more dust out and evaporation from happening. But with that sump open like that, I've only been adding, on a daily average, about 1 quart of water. That's an old school weirdo 3-quart Tupperware. I've been adding like a third of that thing every day right into that return chamber, based on my average evaporation. So the idea with automatic top off is it's a small little drip pump system. You'll have prepared water in here that's good to go for your fish tank. If you do any mineralization or demineralization through water treatment, it can all happen in there first, and you'll satisfy that, and then it will run 10 days or whatever without me having to keep up on it manually. That'll be kind of slick. It's not an emergency for me to set that up right now, but it will be in the future. ATO, automatic top off. The sponges and the pads and the filter where I put in stuff is still going to be an ongoing experiment. I look forward to all that, the way I do it. I may do a K1 moving bed in here at some point. I like the idea of doing that. I can work with Metalla filter mats up against that wall to stop and keep that shit on that side and from flowing over through. Oh, flood protection. I can't remember the name of the company, but the product is called Pump Stopper. It's a company out of Chicago that does switches and electronics and stuff that has had success with this. So I want to, what happens if those drains slow down, something stops or whatever in the drain system? These pumps don't know any better. They'll flood the display. I got 25 gallons of water here, and I don't have 25 gallons of headroom in the display, right? So that's no good. The idea would be to put a float switch up in the display, set the emergency level. When it's up near the very top, it'll actually kill the power. I'm going to set it up so it will kill the power to both of my pumps and that UV lamp. And that will be only in the event that one of those two drains gets clogged. I don't plan to have snails or whatever, but if a chunk of plant got through, or I did end up with snails or a fish somehow, I'm going to make covers and prevent that stuff too from happening as much as I can. But if one of those two drains gets slowed down or clogged or whatever, all of a sudden I'm not satisfying it. What if it only slows it down 100 gallons per hour? Well, it's still going to be draining a bunch of water into here, but at that rate, within 15 minutes, I could be flooding this display, and it'll continue to do it for a couple of hours until something runs dry. So what we'll do is, in a real calm area up in the very corner, I got this little float switch that'll go up in there, and it's got a slosh guard and all that neat stuff to stop it from tripping real easily or a fish smacking it. But if the display level wants to flood up close to what would be the rim, the edge of the rim, it'll hit a float switch, and it's going to kill the power to my two return pumps and that lamp. In which case, the rest of the power will remain on. So if it happens when I'm away, no big deal. It won't come back on until I fix it and reset it. But those AC 110s will continue to run, create circulation, and they'll at least turn over 300 gallons an hour, while I'm away, 300 each. So 600 gallons an hour. They'll still turn me over maybe 3 times an hour on this 200-gallon volume. All right, this is ridiculous, but I wanted to cover a bunch of it. Obviously, like I said, the cheap Home Depot plumbing and valves was always going to be just a temporary test thing. I've already got all that stuff in stock, the new PVC, the nice new fittings, the nice new valves. When I shut this down in a few weeks to spray the frame and all that and get it situated, I will replumb that. Replumb the sump. Like I said, I recently put the UV line in, so I used all the new stuff. Oh, I guess I could have pointed out too that over here in this bits, I did set it up for they have clear primer instead of the purple. I'm an advocate for using the primer too, but you can get clear primer for doing the nice fittings so you don't get the purple. I was able to do a pretty clean job once I got started on all that other stuff. I was able to keep the purple all off of it, taking my time. It was good practice when I did that. It's almost been a year. My first couple, I was being haphazardly, and I was like, okay, I gotta stop that. But I've since then got hip to the clear and made myself a nice process with masking tape. There's no dribble. All very clean. It's all glued together 100%. Oh, I did make sure, again, serviceability. So these unions, because they're near the end, I'll be able to access and take apart. That'll be true union ball valve there. Simplifies that, which is nice, but I'll be able to spin that apart, take the returns off. When this is up against the wall, I will not be able to undo those unions. So I have the shortest leg I could. I can reach these unions from the front underneath. I don't need to reach these two on the corners. I can reach around the ends. But otherwise, I made it so I can head on right up in here with my hands and pop those apart for service with ease. Again, gate valves go there to fine-tune the air noise for full siphon. The saltwater guys will end up, I guess I could have mentioned that too, one last thing for this design. We use them more hardware style and just biofilter in the freshwater, but this is the current trend, you know, current flow trend in sumps instead of the old wet dries and all that. Oh, look who's coming. Hi, Sassafras. Are you up from your nap? Hi, Bub. I figured she'd make an appearance. The saltwater guys will run the skimmer in here. They'll build a refugium in here, and it's like a clay substrate. There's a number of ways to make a refugium, but the idea is chemical dosing can happen here in a Triton method, and or chemical and mineral dosing and stuff like that. And then they'll do like a clay bed or peat and weird stuff and grow things in here and let crabs and shrimp go as what they call a cleanup crew. They'll put a refugium lamp right over that chamber so it makes algae grow in this chamber. And they put the cleanup crew in here, certain kinds of snails, crabs, there's all kind of weird shit. I'm not that advanced, I don't know, but they'll call that a refugium section, and they'll actually grow some stuff in there and keep little critters growing in there, and it helps clean up. It induces the growth of the shit you don't want in the display in that area, and then they manage it in that area. That's their idea, their approach in the saltwater setup. We're just using this chambered design in the freshwater and simplifying it. Pack it full of bio, pack it full of hardware, experiment and have fun with it. Oh my God, Bub's gonna jump on me. Oh my God, we're at 49 minutes. I guess we're still going. What, I don't know. Sorry about all the lighting and the glare. Like I said, I'm excited about it though. It's been a long time coming. It's getting near the end of just tinkering with it. I'm gonna move it up, and I think I'm gonna do some half and half on the substrate, probably some black sand, do a deeper gravel bed on one side, and maybe block it out, like wall it up with some of that chunkier log piece of driftwood, and then have a shallower bed of sand on the other half. Because I think loaches and geophagus, earth eaters type fish are going to come in here in the beginning. So it should look pretty sharp once I black out the back. I've got just vinyl window film, privacy film, blackout film. So if I don't like it, I can peel it back off. I didn't want to deal with painting and stuff like that. Clean it up and change it or whatever. Just the neat thing too about the hang-on back overflow is, if I ever wanted to change it later and move this off the wall and turn it into a, what do they call it? Like a, not a lagoon, but like a, not an island or whatever, but use it as like a room divider. You can view it from both sides. So you put the end against the wall or whatever. What do they call that? Peninsula style. Could take that hang on back overflow, hang it right on this end, right, bub? You tell us. And just do a set of quick pipes right down, 2 1-inch right into that. Peel the black off the back, and I can have that as a room divider, years to come if I move this into a different location, whatever I decide. It makes it compatible to, reconfigure it pretty easy. And I bet, no doubt, having those 2 1-inch drains going straight into that pretty much, I bet it would flow faster and smoother for me. I might get more than 900 gallons out, to be quiet. I just, doesn't matter. I've settled in on enough flow, and with the added circulation, my plan is good. I'm in at 6 to maybe even more than 6 times an hour turnover, and man, it runs really crystal clear. And I've really played hell with all the driftwood, the gnarly. I mean, it's almost down to nothing anymore. There was this black hair algae, and let's see, I know let's look in here. There's on the bottom of that. Look at that white nasty fuzz growing out of it. It's like kind of creepy. It looks like all moldy and shit in there, but the stuff was growing out of everything. Nasty everywhere. It's been out of there many times to be brushed off, hosed off, power washed, change filters, reconfigure the pads and try different things along the way and adjust levels and see if I get better results. So it's been fun to tinker with. Sorry about all the wobbling and the glare. This will be fun to rewatch. Whatever. It's a waste of time. It was just to help out a new internet buddy and run a quick experiment. All right. Shut up.